Hello everybody. Now we are going to solve this electric circuit problem using nodal analysis, and this problem is from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. The question number is 3.20. When we are asked to find out current I in this circuit, and the methodology to be used is nodal analysis. So whenever you come across this word nodal analysis, that indicates we need to apply KCL. KCL is Kirchhoff's current law, and this Kirchhoff's current law states that the summation of incoming current is equal to summation of leaving current in a particular node. So this KCL must be applied to the nodes only. Okay, so when you apply this KCL, Kirchhoff's current law, right? So you will get a equation. That equation is nothing but the current equation. So that equation is called current equation, and the terms are written in currents only. Okay. So to this current equation, we have to apply Ohm's law. So the Ohm's law is being applied in this current equation. So after applying this Ohm's law, you will be getting that equation written in terms of voltages, that to the nodal voltages. So that equation available in terms of that V1, V2, V3 like that. Okay. So you will be getting the equations. That equations are called linear equations or simultaneous equations. That equations must be solved, right? That linear equations must be solved. So once you get this equation solved, you get the answer for this V1, V2, V3. That means you will be getting the values of this. This is how we do the nodal analysis. Okay, this is the general procedure. Here we are asked to find out this current I. So after getting the solution for this nodal voltages, you have to see here this V3 is related with I. So here again you need to apply this Ohm's law. That way you will be getting this current I. Okay, so one more step is involved here, but that is not the case with this problem. In this problem you cannot apply this general procedure. So whenever you come across any electrical circuit and given some methodology to solve, you have to have a careful inspection on the circuit. Nodal analysis general procedure is applicable whenever you have the circuit with the current sources only, but here this is not the case. So what is available here? You check it. Here we have this independent voltage source. This is called independent voltage source, and this one is dependent voltage source. So we have actually two number of voltage sources. One is the independent one, another one is the dependent one. On this case the procedure is different. So for this case we go for super node analysis. It is not the simple type of nodal analysis. Instead, it is called supernode analysis. So what is the procedure for solving this? The first step is form the supernode. Supernode or supernodes. So forming the supernode involves some more procedures. What are the procedures and how do you actually identify the supernode? That is another case. How to identify? So in order to form the supernode, you have to identify the supernode. So this is your reference node or the ground, right? This is called reference node. So other than this reference node, we have three more nodes. Node number 1, node number 2 and node number 3. These three nodes are called non-reference nodes. Okay. Node number 1, 2 and 3. These are called non-reference nodes. So if you have any voltage source in between this non-reference nodes, so your voltage source is available in between the non-reference nodes, then you can combine or you can enclose these three things together, and then you can call it as a supernode, and this can be called as a supernode. So in this way we form a supernode. This is simple way of forming the supernode. With this supernode, some other complications can also arise. What it is? So if you have supernode number 1 and you have supernode number 2, and this is one supernode, this is another supernode, and they have a common point here. if you have a common point is nothing but common node. On that case, you can combine these three things together and you can call it as a super node. This is first procedure, simple supernode. The second thing is two supernodes or three supernodes being combined if they are connected with the common node, and we name it as a supernode. So to this supernode, you have a parallel path, and in this parallel path, if an element is connected, so what you need to do is you can combine these together. Now it is named as supernode. So this modified supernode will be the base for analyzing the circuit. In the second case also, so you have the formation of this supernode. So when you have this supernode, how it is being formed? This is formed as a combination of this S1, SN1 and SN2, right? So you have the supernode. To this supernode also, if you have some parallel path in which some elements are being connected, okay. So this is a parallel path. Then you can combine them also and you can form another supernode. This is how we do the formation, right? So I summarize it. So you have the voltage source. These voltage sources are available in between non-reference nodes. Then you can combine them together to form the supernode. And when you have a supernode, to this supernode, suppose if you have any parallel path in which some elements are present, then you can combine these two and again you can name it as a supernode. The other thing is you may have supernode 1 and supernode 2. In between you have a common point. Then you can combine these two and this can be named as supernode. So after forming this supernode, if you have one parallel path in which you have the resistance, then these things can be combined together and now we can also name it as supernode. So this is how we form the supernodes or supernodes. So to this supernode, we need to do the analysis, right? Okay, shall we form the supernode now? Yes. So now we are going to apply the supernode formation. So you check this. Here you have a non-reference node number 1. Here you have this non-reference node number 2. And in between here you have the voltage source, but it is a dependent voltage source. So you can combine them together and it can be named as supernode number 1. And again you check, here you have this non-reference node number 1 and then this independent voltage source is there, independent voltage source. Then non-reference node number 3 is there. So we can combine these things together and you can form you can form supernode number 2. And if you check, the supernode 1 and supernode 2 are sharing this node number 1. So this is called as common point. So once you have the common point and here you have supernode number 1 and here you have supernode number 2, they can be combined and you can name it as supernode. Here also I am going to do the same because this is the common point, okay, between the supernode 1 and supernode 2. So I am going to combine these things like this, right? This is supernode. But one more thing is there, in between this V2 and V3, we have another element. This makes the parallel path. So you can combine this SSN along with the parallel path to make it as a bigger supernode, right? So we form the supernode by combining or enclosing all these things. So you get it. So I said that this 2 ohm resistance is making the parallel path, right? Somebody may not understand how this is a parallel path. For that I'll try to explain you in another way. So make this as V1 non-reference node, make this as V2. In between what do you have? This 2i plus minus, okay, dependent voltage source, and then mark here this V3, and in between this V3 and V1 you have this independent voltage source. So here you have the dependent voltage source, here you have the independent voltage source, and what is the polarity? When you go from this V1 to V3, it is plus and minus. So V1 to V2, it is plus and minus. The polarity is important. This is 12 volts, right? So this configuration is over. In this we formed the supernode number 1 and we formed this supernode number 2. So this acts as the common point. So we can enclose all these three things together to form a supernode, right? But now you understand that in between this V2 and V3, right, I am going to mark this again. I am going to draw this. Between this V3 and V2, you have this element that is 2 ohm resistance. Okay, so I can mark this like this, right? So I can mark it as you have SSN super node. Here you have what? V3. Here you have at the end V2. In between you have the parallel path with the 2 ohm resistance, so that you can enclose them together, and again you can mark it as SSN, right? Supernode. This is how we form the supernode. So now coming to the circuit, you can form the supernode enclosing all these things. That's it. So I'm going to redraw this circuit, because if you enclose all these things, that won't be helpful for you when you do the nodal analysis. So now how to solve this? So what is the abstract form of this? So we are going to draw the abstract after getting the supernode formation. This is V1, this is V2, and this is V3. V1, V2, V3. So here all these things would be actually made as a dummy thing, because these things form you the supernode. After this, here you have the required things, like this is 4 ohm resistance, and here you have 1 ohm resistance, here you have this 4 ohm resistance, and here you have the ground. To this abstract of the circuit, now you apply KCL. Okay, so for that you mark the currents. This current, we take this as I1 current. Here I take it as I2 current, and you can make any direction for this. Okay, you can mark any direction, but this I current is already given in the problem, so this current direction should be the same. So after marking this current direction, we apply this case here. Summation of incoming current is equal to summation of the leaving current, isn't it? I leave. So in that, if I substitute, there is no incoming current, only leaving current, so this can be taken as 0, and the leaving current summation is I1 plus this I2 plus this I. So what is the name of this? This is the current equation, right? So what is the next step in the nodal analysis, ordinary nodal analysis? First one is KCL. Second thing is applying Ohm's law. So how do you apply Ohm's law here? Here it is 0. This I1 current can be written in terms of Ohm's law as V by R, right? So it is V1 by 4 ohms plus this I2 can be written as in terms of voltages as this V2 by 1 ohm, and this I current can be written as in terms of voltages as V3 by 4 ohms. Okay, so this is after applying Ohm's law. So now you got everything in terms of voltages, right? These are available in terms of voltages. So now you got the voltage equation. So what it is? V1 by 4 plus V2 plus V3 by 4, that is equal to 0. Multiplying this by 4 gives you V1 plus 4V2 plus V3, that is equal to 0. So we can take this as equation number 1. So this equation we obtained from KCL actually, right? Okay, so this is the first equation. Okay, now we move on to the second step. In this we need to apply KVL. Okay, so that is Kirchhoff's voltage law. That is to be applied for supernode 1 and supernode 2. So when you look into the supernode 1, it can be written as V1 minus V2, that is equal to 2I. So when you see this consists of voltages V1, V2 and the current I. But we need only voltage equation, right? So this I is to be changed into voltage. How do you change it? Because this I is equal to nothing but V3 by 4 ohms, right? By applying Ohm's law. So I can substitute this into this, substituting this I into this equation. We get it as V1 minus V2 is equal to 2 into V3 by 4. So this can be written like this. So you get it as V1 minus V2, that is equal to V3 by 2. Now multiply this equation by 2, you get it as 2V1 minus 2V2, that is equal to V3. So 2V1 minus 2V2, bringing this V3 to the left hand side, it becomes minus V3, that is equal to 0. So now you got your second equation. Now look at the second supernode, which is here shown with the help of this green color loop. Okay, so there it consists of this V1 and then this 12 volts and then this V3, right? So it can be written as V1 minus V3, that is equal to 12. So this is your third equation. So in terms of voltages, we have all the three equations because we have only three unknowns. These three equations are sufficient to solve the equations to find out these unknowns. So when you look into these three equations, these two equations are having V1, V2, V3, but the third equation has only V1 and V3. So it is better to remove this 4V2 and 2V2 from this. So it is better to remove this V2 variable from these two equations. So we consider this first equation, V1 plus 4V2 plus V3, that is equal to 0, and then take the second equation, multiply it by 2, then you get it as 4V1 minus 4V2 minus 2V3, that is equal to 0. So I write this as 2 dash, modified form of the second equation. Now we can add this first equation with the modified form of second equation. Then these two get cancelled. So that you will be getting this as 5V1 minus V3, that is equal to 0. So we mark this as equation number 4. So we can write this as V3 is equal to 5V1. So this is your fourth equation. So V1 minus V3 is equal to 12, isn't it? That is according to the third equation. Now substitute this value here. V3 equal to 5V1. We can write this as V1 minus 5V1, that is equal to 12. So minus 4V1 is equal to 12. V1 is equal to minus 3 volts. This is one answer we got. So once you get this V1 as minus 3, now you go for the third equation again and substitute this value into this V1. So that you can write this as minus 3 volt minus V3, that is equal to 12. So V3 is equal to 12 minus V3 is equal to 12 plus 3. That means it is 15, right? So V3 is equal to minus 15 volts. So we got the answers. V1 is minus 3 volts and V3 is equal to minus 15 volts. But the question asked us find the current I. So I can be written as using Ohm's law as V by R, right? So this is equal to V is V3, R is 4 ohms. So it is minus 15 by 4. So this is equal to minus 3.75 amperes. So we got the answer I is equal to minus 3.75 amperes. So this is a required answer. Okay, thank you. Hope this video is useful to you. See you in the next video.